So have you seen Kafka is a distributed system? We have 3 brokers or 100 brokers, so this is distributed. That's what makes it distributed. And so when there's a distributed system in the big data world, you need to have replication, okay? Such as if a machine goes down, then the thing still work. And so replication does that for us. So here is our cluster with 3 brokers, and we're going to create a topic. And topic, when you create them, you need to decide on the replication factor, as you'll see on the hands-on. But usually, the replication factor is between 2 and 3. 3 being the gold standard. 2 is a bit risky, but 3 being the gold standard, okay? When you create a topic, you want it to be replicated. This way, if a broker is down, and we'll see this in a second, then another broker can serve the data. So here's an example, hands-on. So we're going to have topic A with 2 partitions and a replication factor of 2. So this is my topic A, and partition 0 got assigned to broker 101, and partition 1 got assigned to broker 102. Now, because there's a replication factor of 2, we need to see 2 replicas of these partitions somewhere. And so partition 0 of topic A is also going to be replicated on broker 102, and partition 1 of topic A is also going to be replicated on broker 103. So as you can see, I drew an arrow between the partitions. It's because they're linked. There is some replication happening. And so replication factor of 2 means that you have 2 copy for each data. So 1 orange box and 2 orange box, so that's replication factor of 2, okay? And same for the light orange, 1 and 1, so that's replication factor of 2. So when we created a topic in the previous lesson, that was replication factor of 1. So now that we have some replication factor, let's look at what happens if we lose broker 102. So we lose broker 102, and as you can see, broker 101 and 103, they can still serve the data, okay? Even though we lost a middle broker, the broker 101 and 102 still have a copy of the data. And so that's the trick with replication factor. It's the cool thing. So to run the example, if you take down broker 101 and 102 and 103 are still up, then you can still serve the data as well. So the replication basically allowed us to ensure that data wouldn't be lost, or then would still be able to be served. So now that we have replicas, in Kafka, there's a concept of a leader for a partition. And so golden rule, at any one time only, one broker can be a leader for a given partition. Only one. And only that leader can receive and serve data for a partition. The other brokers will just be passive replicas, and they will just synchronize the data. Therefore, each partition is going to have one leader and multiple ISR. ISR in Kafka world, that means in-sync replica. So let's have a look at the previous example. This time, for partition 0, broker 101 is going to be the leader, while broker 102 is going to be a replica, or ISR. And so as you can see, the replication goes from partition 0 on broker 101 to partition 0 on broker 102. Similarly, for partition 1, there's going to be broker 102 that will be the leader for partition 1, and then the replication will happen all the way to partition 1 on broker 103. And so that's the important thing. As you can see, there's a leader and there's a bunch of ISR or in-sync replica. And so what decides leaders and ISRs, we'll see it's called Zookeeper, okay? It's not something you have to worry about, but there's also a question that says, what if broker 101 goes down? Is there an election that happens? Yes, if broker 101 on the left-hand side is lost, then the partition 0 on broker 102 will become the leader because it was an in-sync replica before. And then when broker 101 comes back, it will try to become the leader again after replicating the data. So this is happening for you in the background, just for you to know about it. But all of this is handled by Kafka, and the leader and the ISR is determined by Zookeeper. Okay, so that's all for the replication factor for now, and I will see you in the next lecture.